So we have an ArrayDeque. An ArrayDeque is a concrete class that implements one of two concrete classes that implement the deque interface. The other one is linked list. So I'd like to just highlight some of the implementations of ArrayDeque. So here, I'm just going to go through an introduction, the hierarchy of ArrayDeque, the ArrayDeque class declaration, the features that define an ArrayDeque, the constructor, the method, and some examples of ArrayDeque. And so quick introduction. So an ArrayDeque in Java is a concrete class that creates a dynamic array, so a resizable array that stores elements from both sides of the queue. So we use ArrayDeques already when demoing out our deque. So it provides a resizable array implementation of the deque interface. Therefore, it is also known as an array of double-ended queue or simple ArrayDeque. So since ArrayDeque has no capacity restrictions, ArrayDeque is especially useful for implementing stacks and queues whose size are not known in advance. So the ArrayDeque was added in Java 6. And it was added into the Java collections framework, which is what we've been learning about. And it's present in the java.util.ArrayDeque package, which we've already seen. So just a quick hierarchy and examinations of the hierarchy is we have the ArrayDeque class that implements the deque interface, which extends the queue interface, which extends the collection interface, which extends iterable. And so all implemented interfaces by ArrayDeque class in the hierarchy are, it also does serializable, clonable, iterable, collection, deque, and queue. So all the methods defined in there, in any one of those interfaces, ArrayDeque would have access to. A quick examination into the ArrayDeque class declaration. So public class ArrayDeque, and it uses generic typing, extends the abstract collection class, and it implements the deque interface, the clonable interface, and the serializable interface. And again, any place that you see an E is the generic typing. Some key features that are worth knowing about ArrayDeque, especially as we are really comparing them against linked lists, is that the ArrayDeque class provides a resizable implementation of the deque interface. Well, that's the same for either of those. Two, it has no capacity restrictions, so it can grow according to the need to handle elements added to the collection. Well, that's the same for both linked lists and ArrayDeque. ArrayDeque is not synchronized. None of these have been synchronized, so they're not thread safe. So just be aware for all these data structures, that will be true. Now, null elements are restricted in the ArrayDeque. But okay, here's where it starts to get interesting. So ArrayDeque class performs faster operations than stack when used as a stack, and ArrayDeque class performs faster operations than linked list when used as a queue. So we probably won't look at it. There is actually a stack class, just like there's a linked list class that's implemented inside of Java, but the deque, the ArrayDeque, is a faster implementation of either of those for using LIFO or FIFO operations. And then the iterators returned by the ArrayDeque class are fail fast. So that just means that if the deque is modified during iteration, the iterator will throw an exception to go ahead and prevent that. So the constructors for a ArrayDeque, there's the default constructor that just creates an empty ArrayDeque. And so the initial capacity is 16, but it can grow to however many elements you need to add into it. You can also add a number that specifies how large you'd like the size of the ArrayDeque to be. So for instance, in this example, we're going to make the underlining array 5 elements large. So this is typically good if you know it needs to be a particular size or larger than 16. That way you don't have to grow it automatically. And of course, if you try to put in a value less than 1, it'll throw an exception. You can also, just like all the other members of the collection framework, pass in a collection object, and it can be then converted into an ArrayDeque. And let's take a look at some of the ArrayDeque methods. all the methods that ArrayDeque has, so that it has no methods of its own, but it inherits all the methods from deque, queue, and collection interface. And so the important ones to recall are going to be being able to add elements and being able to add first, being able to add last, being able to clear the elements from your ArrayDeque, and being able to clone your deque. Some other methods that are worth looking at is being able to see if your ArrayDeque contains an element. The element method is used to retrieve an element from the head of the deque, but doesn't remove it. You have a get first method that's used to retrieve the first element of the deque, a get last that retrieves the last element of the deque, an is empty method that returns whether your deque is empty or not. You have an offer first and an offer last, because again, this is a double-ended queue. So you have the ability to insert the specified element at the front of the deque. You have the ability to insert the specified element at the end of the deque. You have the ability to peek that retrieves the element from the deque, but doesn't remove it. And that's the one that will go ahead and if the deque is empty, it returns null. You have the ability to peek first and peek last, which retrieves the first element and the last element. Because remember, peek was a method that it inherited, but also peek first and peek last are methods that it inherits from the deque interface. And then poll and poll first retrieves and removes the first element of the deque or the head of the deque, and they both return null, but it's inherited from two different interfaces. So poll first and poll last allows you to specify whether you want the first or last element. Poll by default just as the first element, right? So again, we're getting more methods from our inheritance of deque that allows us to have double-sided access, but then we need to specify whether we want to poll for the first or the last. We get the pop and push methods that allow us to treat our ArrayDeque as a stack. So the pop pops the element that's at the head of the stack, and push pushes something onto the head of the stack. We have the remove method, which is used to retrieve and remove an element from the deque. The remove first is the method used to retrieve and remove the first element from the deque. Remove first occurrence removes the first occurrence of that object from the deque. And then we have the ability to check the deque size or to get back the deque as an array. We can request an iterator or descending iterator. We saw actually both those in the last deck of slides, where the iterator goes in ascending order, descending iterator gets an iterator in reverse order. And so I just want to look at some examples, and then we'll be done with Unit 2. We'll be done with our data management portion of this class. So let's talk about how we might add elements. Let's create a program where we add elements into our ArrayDeque using the add first, add last, offer first, and offer last. And I believe this is not dissimilar from what we did in the last example. So here, let me go to my ArrayDeque tester. And here I'm just going to go ahead and import my concrete class, ArrayDeque. I'm going to create a new class. I'm going to create a main method. We're going to create an ArrayDeque variable, and we're going to use generic typing to hold in integer values. And we're just going to use the default constructor to create a new ArrayDeque. Here, let me run this to make sure that as we iterate through, I can talk about what's happening. Here, we're going to add 10 into our deque, our ArrayDeque, and then I'm going to add first 20, and I'm going to add last 50. And then I'm going to offer 30, offer first 50, offer last 40. And we're going to print out that state. We're going to see what happens. And you're going to see, well, 50 is first because that's the last thing that was in the offer first. And then the next thing is going to be the 20 because that was at the add first here. So, and then what we have is we have 10, which was our add method. That's the first thing we added in. So that's like the root. So then we added 20 in front of that. And then finally we added 50 in front of that. Then I have 5 because that was add last here. So that was the last element. But then we did an offer. And so an offer is going to put that after the 5. So that's here. And then we're going to do an offer last, and that's going to be our 40 here. Okay, let's take a look at another really brief example where we're going to create a program where we access elements using methods like the get first, get last, all the different kind of getter methods. So here, let me run it. So just a small little program where we're going to import our ArrayDeque. We're going to create a new class. We'll create a main method. I'll create a new instance of an ArrayDeque using the default constructor that holds integers. We're going to call the add method to add in some integers, so 25, 50, 75, 100, 125. And then what we'll do is we're just going to print out the state of our ArrayDeque here, 25, 50, 75, 100, 125. And then we'll be able to just query, get the first element, get the last element. And you can see we can get the head or the tail, 25 and 125. And then I just want to show you an example program where we can remove elements using remove first or remove last or pull or pop or pull first or pull last. So here we're going to import our ArrayDeque. We're going to go ahead and create a class of ArrayDeque tester. We're going to create a main method. I'm going to create an instance of an ArrayDeque using the default constructor. This time I'm going to create an ArrayDeque that holds string data types inside the generic typing. Here I'm going to add the string of 1, and I'm going to add as the first element in front of string of 1, 2, and then I'm going to add to the end, to the tail, last 3. So let's actually run this here. So if I print out the state, I'm going to have 2 be the first element, then 1 is going to be in the middle, and 3 is going to be the last element. That's exactly what I should expect it to be. And now I'm going to do some operations. I'm going to pop. So when I pop, I'm going to pop from the head. So that's going to return back to me the value of 2, right? And so then my deck would then hold 1 and 3. And so then if I pull, which removes an element as a Q from the front, is going to remove the 1. So I can pop, I can pull, both those are kind of similar. I can also pull first, that removes the element from the end. So that's going to be my 3 now, that's the very last element. And finally, I'm going to pull last, and that'll remove the element from the back end. But there is no more elements, but pull returns back null when there's no more elements. So just an illustration that I can remove in 2 different ways from the front and the back. And again, it's the removing that makes these interesting, decks interesting. And then I just want to show some quick examples on how to iterate over the elements of a deck. And so an ArrayDeque can be iterated over elements from both ends using the iterator and descending iterator. We've seen this example in the prior slide deck, but I kind of want to show it in this slide deck as well. So just a quick example, we'll go ahead and import the ArrayDeque class. We'll import the iterator class. We'll create our ArrayDeque tester 4 here. We'll declare a main method. We're going to create an ArrayDeque that holds string data types. We're going to add some strings in there using the various methods. So we're going to add 1. Then in front of 1, we'll add 2. Then after 1, we'll add 3. And then we'll add 4 again. And again, let me run this so you can see what the state is going to be. Okay. And so what we're going to do is we're going to call the iterator method to get an iterator that returns back strings. And we're also going to do a descending iterator after this one. So on the iterator method, it's going to iterate in ascending order, so from head to tail. So long as we have another element, we'll go ahead and walk across. We'll get the next one. So we're going to get the 2, the 1, the 3, and then finally the 4. That's exactly what we'd expect to have. So now if we want to do descending iterator, right, I'm going to save that in iterator variable. I'm going to on iterator 2, so long as I have a next element, walk across it and get it. And here I'm going to go backwards, 4, 3, 1, 2. So I can go forwards or backwards with either of those iterators. And then for the last example code, I want to create a program where we can use the ArrayDeque to create a stack. And because again, that's going to be one of the bigger use cases of ArrayDeques is, and if you ever need to go ahead and implement a stack. And so here, it's super simple. I'm just going to import the ArrayDeque. Then I'm going to go ahead and create a class, ArrayDeque tester 5. I'm going to create a main method. I'm going to create a new instance of an ArrayDeque using the default constructor. I'm going to save that into a variable. I'm going to use generic typing to declare that this is ArrayDeque of strings. Here, I'm going to create an initializer list of an array of strings that I'll call weekdays. So this is a string array, a primitive string array, right? We probably haven't seen this in a little bit of while since we've been looking at all these advanced collections. But here I have Sunday, Monday, Tuesday, Thursday, Sunday, Monday, Tuesday, Thursday, Friday, Saturday. Missing a day there. That's fine. Let's run this. Okay, and so what we're going to do here is we're going to iterate for each string weekday. So this is a local variable weekday, and we're using an enhanced for loop. So we're going to walk across this array of weekdays. Then I'm going to push that weekday onto my stack. So I'm going to use the push method. And then once I have my stack filled with all of these elements, I'm going to I'm going to do a while loop and peek to see, so long as I have an element that's not null, I will pop it and print it. And we can see when I pop those elements off the stack, with a stack, the last one on should be the first one off. So as I push these in, and if I look in the order, it should be Saturday, Friday, Thursday, Tuesday, Monday, Sunday. Yep. So it should be able to pop those off in the reverse order. And so there it does. And so that's it. That's all I kind of want to say about ArrayDeques. And that kind of completes our examination into the collections framework. So at this point, you should have a deep understanding of all the different collections, the container classes that you can store data in, and all the different behaviors for inserting, for retrieving, for writing, updating, reading inside those containers. Usually we can kind of call those CRUD operations, what it means to like create an element, to read an element, to update an element, or to destroy or delete an element from a container class. And so like sometimes ordering matters, and ordering could be defined by like when's it inserted, or how's it sorted, like based off of priorities. And there's just a number of different ways that we can do this. And so you'll learn a lot more about this when you hit data structures. Excellent. Does anyone have any questions about this particular set of slides? If not, I will end this lecture here so I can start with the so that the video can start compiling. And if you have additional questions, then I can just open up another meeting that you can join into. So that's what I'm going to do. If you need any assistance, I'm going to end this meeting, and then I'll launch up another meeting on our normal URL.